Hello everyone, I welcome you all to Startup Academy, India's exclusive coaching for ISS examination. In the previous lecture, we did some of the tricks for Poisson distribution, in we can both use in our distribution theory part, which is for paper one, and in inference part, which is for paper two. And in today's lecture, we'll be dealing with another distribution, which is binomial distribution, which forms the basics of our statistic theory. And today also we are going to distribute the theoretical part and the pattern between among the PMF, UMBUE, and the pattern of we'll be learning the pattern of our estimation theory in this, which is beneficial for both our paper 1 and 2 simultaneously. So this is also one of the crucial videos which you will require in your upcoming examination. This is just a revision and forms a new concept for you all, so that you all can see how and when we can use these concepts in the class, in the examination. Okay, so let us begin. Today's topic is binomial distribution. Now we all know that what is binomial distribution. Binomial distribution is a discrete distribution. So if we have a variable x and it follows binomial distribution with parameters n and p, then the p and f, because it is a discrete distribution, so we will be writing the, let us take it as yellow, the PMF of binomial distribution as NCX p raised to the power x and 1 minus p raised to the power n minus x, and we can take it as q raised to the power n minus x for all x goes from 0, 1, 2 and so on. This forms our binomial distribution PML, and this will be beneficial for us in the upcoming pattern. So as we first of all we'll be discussing the pattern of distribution theory. So as we'll discuss first kind of pattern, which is of paper 1. Okay, this is we are discussing for paper 1. So suppose we have a random variable x following binomial distribution n comma p, and we have to find expectation of x. Now we all know that expectation of x is nothing but np. But how does it come? First of all, we'll see the derivation. How did it come? Then I'll tell you the pattern regarding this. So when we talk about expectation of x, this will be summation x goes from 0 to n, not infinity, it is n, and x into ncx p raised to the power x and q raised to the power n minus x. But if we take x as 0, then the first term will be 0. So instead of writing x goes from 0 to n, we can write x goes from 1 to n. Now here we can see that we can take the common things outside, or we can take alpha. Here we can take minus x and put upon q, this as this, and let us take p upon q as let us take it as equal to alpha. Let us suppose it is equal to alpha. Then we can write this as alpha raised to the power x. Okay. Now we can open this summation and we'll be getting q raised to the power n will come outside. So it will be summation x goes from 1 to n, x, n, c, x, alpha raised to the power x, right? We can open this bracket, it will be q raised to the power n. If we take x equals to 1, it will be 1 nc1 alpha raised to the power 1 plus 2 nc2 alpha raised to the power 2, and so on till n ncn alpha raised to the power n. We can do this. Now we know that one of the theorems is, if we talk about 1 plus x raised to the power n, if we talk about this, then this will be 1 plus nc1 x plus nc2 x square, and so on till ncn x raised to the power n. This is our theorem for that. Okay, but here if we compare this with this, the first term we should get is 1 into nc1 alpha. So we have to convert this into this. So it will be, if I have to convert 1 into this, then I have to multiply nc1 here, which will be n minus 1, alpha raised to the power 1 also, which will be x here, and one more thing we'll multiply, which is n, because see 1 2 3 n are getting multiplied, so we will be getting it equal to n. Okay, then this summation will be equal to the one that we have above. So we'll directly write this whole here as q raised to the power n 1 plus, this will be equal to x n 1 minus alpha raised to the power n minus 1, and here x is nothing but alpha only, so we will be taking alpha. Okay, now from here we can see that 1 plus alpha, sorry, from here we can see that alpha is nothing but p by q. So instead of writing alpha, we can write here p upon q, p upon q. Here if we take LCM, it will be p plus q upon 1, and p plus q is nothing but 1 only, so it will be 1 upon q. Now this bracket, q raised to the power n minus 1, and this q and q raised to the power n, all these three terms will get cancelled, and we will be left with np, which is our expectation of binomial theorem np. Okay, which is also our mean. Now we've got this. The second thing, that if we have to find expectation of x minus 1, then what will we do? So similarly, we'll take summation over x goes from 0 to infinity, x minus 1, ncx, p raised to the power x, and q raised to the power n minus x, and we'll continue like the way we did for the previous one. We'll take x goes from 0 1 to n, not infinity, n. X goes from 1 to n, and instead of writing minus q here, we'll write q here, and so on, and finally we will be getting expectation of n x minus 1 as n minus 1 p square. Okay, in summation term we'll be adding these terms. The final summation will be q raised to the power n outside, q raised to the power n n minus 1 p square upon q square, which will be p upon q raised to the power x, into 1 upon q, which will be p plus q, which will convert to 1 upon q raised to the power n minus 2. So this q term and this will get cancelled, and the final answer will be getting n minus 1 p square. So and so on, if we take expectation of x x minus 1, x minus 2. Then we will be getting it equal to n minus 1, n minus 2, p cube, and so on. So this will form the basis of our theorem, and this is the pattern that we see. So the general pattern I can write it as x minus 1 up till x minus k is equals to n minus 1 up till n minus k p raised to the power k plus 1, because here k was equals to 2 and p raised to the power is 3, so it will be k plus 1, and so on. We can find any value for k. Now suppose in examination they ask you that you have to find, suppose the question is there that x follows binomial distribution with parameters n and p, and we have to find expectation of x squared minus x. Now from here we can see that this can be converted to expectation of x minus 1, right? And we all know that expectation of x minus 1 is nothing but n minus 1 into p. And similarly they can give you, suppose they give you this expectation of x cube minus 3x square plus 2x. Now if we take things common outside, then we will be getting this as nothing but x minus 1, x minus 2, which will be nothing but n minus 1, n minus 2, p cube. It will be p square. Okay. Otherwise, first of all, you would have been calculating expectation of x cube minus 3 expectation of x square plus 2 expectation of x. And we all know that only this thing, and for this and this we had to calculate. So this will take a lot of time in examination. Instead, we can directly use this pattern for solving question. Now suppose there is one more question which tells us that x follows binomial 1 comma p. Now here n is equals to p. So we can see that expectation of x is np, which will be 1. Okay. Expectation of x minus 1 will be equal to what? n minus 1 into p square. But n is equals to 1, so this will become what? 0. And similarly, other expectation greater than 2, greater than and equal to 2, expectation of x minus 1, x minus 2 will also be equal to 0, because there also n minus 1 will come and 1 minus 1 is 0. So for binomial 0 1 p, which is also Bernoulli distribution, the formula, the mean will be p, and after that expectation will be 0. And if we have x follows binomial with parameters 2 and p, then it will be expectation of x will be equal to 2p np. Expectation of x minus 1 will be equal to n minus 1 into p square. N is 2, 2 into 2 minus 1, p square will be 2p square, right? And expectation of x minus 1, x minus 2 will be equal to n minus 1, n minus 2, p cube. Here 2 is coming, so 2 minus 2 will be 0, so it will be equal to 0. So for binomial 2 with parameters 2 and p, our first and second pattern will show some value, but from the third pattern onward, the third value of p, it will be 0, and so on. This will continue. So this is the pattern for your sampling theory or the distribution theory for paper 1. Now if we talk about the second theory, which is the second paper, inference. If we talk about inference, Then if we have to find, suppose we have been given x follows binomial distribution with parameter n and p, and we have been given a statistic t which is equals to summation I goes from 1 to, let us say, k xi, and we have to find, suppose the question says that umv ue of p cube. Suppose we have to find this. Now, first of all, we have to check for the UMVUE, we have to check that whether this T is the sufficient and complete statistic. It is sufficient and it is complete. So, any unbiased estimator or function of T will form our UMVUE of binomial distribution of this X of P cube. Okay. So we all know that P cube will come when we take expectation of T, T minus 1, T minus 2. Then it will be equal to N, N minus 1, N minus 2 into P cube. We only had to find this term P cube here, which we have find out here. Okay, we have found out. Now we have to find the unbiased estimator of P cube. So all of these terms will come in the denominator for this. It will be expectation of T, T minus 1, T minus 2 upon N, N minus 1, N minus 2. This will be P cube. So this term, this whole term forms the UMVUE of P cube. It is as simple as this. And one more thing is there, for all n is greater than 2. For all n greater than 2. Or we all can say for all n greater than 2 or n greater than equal to 3. Because if it is equal to 2, then this will become infinite, which is impossible because this is 0. So hence we have to mention this condition as well. And in the exam there might be any condition regarding this. But if we have to, this in here, we have found out the UMVUE of P cube. But if we have to find UMVUE of P raised to the power 6, let us suppose. So we all know that expectation of T, T minus 1, T minus 2, T minus 3, T minus 4, T minus 5 is nothing but n, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5, p raised to the power 6. We have got p raised to the power 6. This we all know from the sampling theory or the distribution theory. Now expectation of t, t minus 1, t minus 2, t minus 3, t minus 4, t minus 5 upon n, n minus 1, n minus 2, n minus 3, n minus 4, n minus 5 is equals to p raised to the power 6. So this, all of this is the UMVUE of p raised to the power 6, where t is nothing but equal to summation xi, I goes from 1 to n. Okay, we have taken n, but previously we took k. Instead of k, you can write n here because we are taking n. Instead of n, if we would have taken k, then it would be k here. Okay, so this is the UMVUE, and T is complete plus sufficient statistic of our binomial distribution. And so on, you can carry for an ample number of questions here. And in the given in the examination, they will be given many number of options. So you have to find just p raised to the power 6 is there, minus 1 till 5 you have to find. P raised to the power 3 is there, so till 2 you have to find. Okay, the options will be nearby only. And here n is greater than equal to 6 or n is greater than 5. Here this will be mentioned. So this also forms the pattern, and this forms the pattern for our inference, and the previous one forms the pattern for our distribution theory, and both are very useful in our examination. For our examination, they can be asked directly or indirectly. So I hope that you understood this concept very clearly, and if you have any doubt, then you can ask us in the comment section. We'll be happy to give answers to your questions or your queries. And those students who are preparing for ISS 2027, we have recently launched a new batch, which is Lakshya 2027, and it will be starting on July 15th, 2026, and enrollments are open. You all can enroll right now, and we'll be taking very limited number of students in our batches. So hurry up and join now.